Hi everybody, it's Mrs. Cassill here to put the notes onto your foldable for emotion, vocabulary, and mathematical relationships. I want to remind you, I'm going to go fast through these vocabulary terms. If you need to write down what I'm showing and reading to you, please press the pause button. If you need to review something that I covered, remember you can always rewind this video. Go back, listen again, read again. And for those of you who are like, oh my gosh, I just want to see the finished product and I can't stand the sound of your voice, I'm not offended. Fast forward. All right, so this is what you've constructed in your notebook. Here is what the finished foldables are going to look like. Okay, so we're going to start by putting the terms on the front in pairs. These pairs are going to be terms that we can compare and contrast and are put together in this order on purpose. The first two on the left is origin, on the right is position. The next pair on the left is distance, on the right is displacement. Next pair on the left is speed, on the right is velocity. I really should redo my nails. On the left of the next pair is constant, that is contrasted with acceleration. Next pair on the left is initial, on the right is final, and the final pair on the left is rest, on the right is motion. Remember, you can pause and rewind if you need to go back and look at those terms. Okay, origin and position. So on the back of each tab is where I'm going to be putting the information about what each of them means. I'm going to zoom in the screen to do that before we get started. Bam! Movie magic. Origin is a term you know from math. This is where all values are equal to 0, especially spatial values. In physics, you define the coordinate system, so you set where the origin is. Position, on the other hand, is where an object is at a specific instance in time. This location is relative to the origin. Without having an origin, you cannot measure the position of an object. To compare and contrast these two terms, the origin, the values for an x, a y, a z, any coordinate are always equal to 0. But for position, that object can be anywhere, including at the origin. It could be at position 0, 0, 0. Our next two terms, distance and displacement. Distance is how much ground an object covers during its motion. You're familiar with this term. The additional term here is this is a scalar quantity. The distance an object travels has no connection to what direction it does that traveling in. We measure distance using the metric unit meters, abbreviated with a small m. Displacement, on the other hand, is a really technical term. This is how far out of place, right? Displace an object is. It's an object's change in position. This is a vector quantity. That means it's not only a distance measured, but it's a direction. What direction out of that first position is that object? It also is measured in meters. Here's an example that compares and contrasts the two. If you were to start here and walk in a rectangular path, first traveling 2 meters downward, then 4 meters to the left, then 2 meters upwards, and then 4 meters to the right, you would end up back where you started. If you were a car driving that distance, or if you were measuring how many steps you took, you would have traveled a total of 12 meters of distance. But your displacement would be equal to 0. You are back where you started. You are 0 meters out of your initial place. Your distance is 12, but your displacement is 0. Our next two terms are speed and velocity. You measured speed in middle school or perhaps in your freshman science class. It's how fast an object is moving. You have lots of life experience with this. Again, this is a scalar quantity. That means the direction that your speed is being directed in has no bearing on how fast you're going. 35 miles per hour forwards is the same as 35 miles per hour backwards. We measure speed in meters per second. We calculate it by taking distance divided by time. Remember, distance is a scalar quantity also. Velocity, on the other hand, is different than speed. It's a vector. The rate at which an object changes position has magnitude and direction. Your velocity can be positive or it can be negative. That tells you which way you're going, which direction. Instead of being distance divided by time, it's your displacement divided by time. Here's an example that compares and contrasts the two. We've got a speed limit sign on the side of the road that says 35 miles per hour. Your speed doesn't depend on what direction you're traveling. If you're driving 40 miles per hour, a police officer could give you a speeding ticket no matter if you were traveling down the road that way or traveling down the road that way. Let's imagine instead it was a velocity limit sign, and you had a velocity limit that said you could only go 35 miles per hour in that direction, that was the limit placed on your motion. Well, then you could go 90 miles per hour in the opposite direction if you wanted. Your velocity would still be less than the velocity limit because your direction would be in the negative direction. Our next two terms compare acceleration with what it means to be a constant. You have life experience with acceleration. This is the rate of change of an object's velocity. In normal speak, it's speeding up or slowing down, right? This is a vector quantity. The direction that you travel makes a difference in your acceleration. This is like the little kid who, once hitting a home run at a Little League baseball game, runs to third base instead of first base. Technically he hit the home run, but he's not traveling the bases the same way as required by the rules to score the run. The unit for acceleration is meters per second squared, and we'll look at some math later that shows where that comes from. A change in an object's velocity includes speed or direction. If you're driving forward and you turn to the left or the right in your car, you just accelerated. If you're driving forward and you press the brake so that your velocity decreases, you have a change in velocity in the negative direction, you accelerated. This is different than how we use the word acceleration in normal life, where we mean it only to speed up. In physics, acceleration can mean speed up or slow down. Constant is a word that you'll see often when describing the motion of an object. Constant means unchanging over time. So when we think about position, constant position means your displacement is 0 meters. Velocity means that your acceleration is 0 meters per second squared if you have a constant velocity. So here's a little cartoon to represent how these two things vary. You could have two objects, both of which are moving at a constant velocity. One that's moving at a slow constant velocity, so each time interval it only travels a small distance. Or you could have something with a fast constant velocity, so that each time interval it travels a greater distance. Or you could have an object that's accelerating, where for each time interval the rate of change of its velocity is increasing. It's getting faster and faster as time goes by, which means the distance it covers in that amount of time is increasing exponentially. Two other terms that you'll see frequently as we look at motion scenarios and problems are initial and final. Initial is a synonym with beginning or starting. We represent it with an I, or some texts will use a 0. So X with a subscript I means initial position, where an object is starting. V with a subscript of I is initial velocity. What's the starting velocity of that object? When we say start, what we mean is when time equals 0, when our stopwatch says 0 seconds. On the other hand, final is the ending of some criterion. So X with a little f is our final position. V with a little f is the final velocity. The final time is usually something that we can measure, something that's given, and occasionally something we have to solve for. So here's a scenario that compares and contrasts these two. So if a person's standing on top of a building that's 10 meters tall and throws an object off the side of it, well, the initial position of that object up here at time equals 0 when they started throwing the ball, it's 10 meters from the ground, if the ground is defined to be our origin. The initial velocity of the object is 0 meters per second. They're tossing this thing off the roof. At the moment they let go, it has no initial velocity. What happens to it? Gravity starts to speed it up in a hurry. The time for that initial condition is 0 on our stopwatch. The final position of the object after it goes shoo and hits the ground, the final position is going to be 0 meters. The final velocity of the object is going to be 39.2 meters per second. And I did some math that you'll learn how to do later. This is a negative velocity. We define the origin as this direction. Positive 10 meters up here, which means moving upward is our positive direction. Moving downward is our negative direction. The time at which these final measurements are taken is 4 seconds. That's our final time. Our final two terms on this foldable are contrasting rest versus motion. Both of those words will be used in problems. So, objects at rest stay at rest without a net force acting on them. So this term rest we'll use in this unit and in our next unit that's about forces and collisions. Being at rest means you're not moving, means your displacement during whatever time interval you're at rest for is 0 meters, means that your velocity during that time is 0 meters, means your acceleration is 0 meters. Motion, on the other hand, an object that's in motion, it too stays in motion unless a net force alters its motion. Motion literally means moving. Lots of words describe motion. Motion can be constant. Motion can be changing or accelerating. Motion can have direction. It can be forward, it can be backwards, it can be left, it can be right. It could be north, south, east, west, or a combination of those described with an angle. To look at a long-term problem and compare these terms, if somebody was running a race, while they were waiting for the starting gun to fire, they would be at rest. Their initial velocity would be 0 meters per second. Once the firing gun goes off, they accelerate. They immediately change their velocity. Usually at the beginning of a race, a person accelerates until they kind of top out and they reach their highest speed. Then they're traveling at a constant velocity. When they reach the finish line, many story problems will ask you to analyze that instant in time as the final time interval. A person right afterwards might slow down and come to a stop and take a rest, literally in some cases, and have a final velocity of 0 meters per second. But most of the time, when a problem asks you to analyze final velocity, they're thinking about this final state of motion at that final time that's being evaluated. Okay, thanks for learning with me. Remember, pause, rewind, and review these notes. Good luck as we go along.